seconds. All right, we're up and running. Welcome. I'm going to share my. By the way, I've learned something about sharing screen. Last time I was trying to change between sharing this, sharing that. I think I've got a technique that will not create that problem again. I'm going to be sharing my whole screen. And that way all I have to do is bring different things into my screen and out of it, and I don't have to change the sharing. So anyway, I'll share my whole screen now. So hopefully all of you are seeing a slide that says Chapter 1, Review Functions, Graphs, and Limits. Let me know if that's not the case. So you already knew this is our Chapter 1, the beginning of our review. We're going to have 2 days, this one and then also tomorrow. First, I want to give a reminder to everyone. If you are connected, speak up if you have a question. Like I said in class the other day, it's very efficient. You can also use the chat window. I would give you a little reminder here. If you go to the top left of your screen with your mouse, you should see a blue chat icon, and if you click on that, it opens up this column on the far right. And you can ask your questions that way if you'd like. I'll try to keep my eye on all of that. And of course, my slide reminds you that you can text me at the number shown there. And just a kind of an informational question for all of you. I posted the quiz grades about an hour, maybe hour and a half ago. And just want to remind you, you might want to go check there. Okay. So let's start off with up here. And in order to do that, you should be seeing my new screen now. And I've got it live. So I don't know if you guys remember how to do this, but you've got the 3 options. As you can tell at the top there, you can go right on the web page, polev.com/rbelo, or you can send me a text message. Send the text message to that destination there, 37607. And then, of course, what you send me depends on which column you answer. And I've got it set up so each of you can respond twice. So I can take up to 2 responses. There we go. We're getting some now. Obviously, you guys are seeing things, or we wouldn't be getting some answers here. We'll let that run a little while, give you a chance. So pick your top 2, okay? I'll just read them just in case the pictures cover up on the bottom. The first column is the Cartesian plane distance formula. The second section, graphs of equations. The third, lines in the plane and slope. Functions is the 4th one. The 5th one is limits, and the last one is continuity. That one that we just finished up the other day. And continuity was the one you guys had the quiz on. Yeah, those people that are on video only, might take them a little bit longer to respond because they have about a 10-second delay. So again, I'm just going to hang on a little while. Yeah, thanks to all of you for responding. I don't know, we'll see. I'll maybe just come back and check on this. But obviously we have three categories. The first section, the fifth and the sixth. One, two, three. Yeah, the fifth and the sixth, continuity and limits. A little bit surprised at the first one, but that's important to know that that first section needs review. That's very important too. So I'll maybe check back on this, but for the time being, I'm going to send, we'll put that in the back. You guys can keep voting. And we'll just check back on it later and see if things change at all. So in the meantime, I can send this to the background, and we'll move. I'm going to start with the section 1 that you guys picked out. Okay, and so here's an example of a problem from that first section where you were asked to find the distance between 2 points. The graph is really not necessary, but the whole idea here is, do you know the distance formula, and do you know how to make use of it? I mean, knowing the distance formula, this the one in the top corner here, I'll just highlight, this one right here. It's really just the Pythagorean theorem, right? Really what the distance formula is. And then you notice I usually will nail down, because I find I make less mistakes if I nail down which point is my point 1 and which one is my point 2, then I don't accidentally swap them halfway through. If you do that, it'll mess up your results. Further down here, scroll down a little bit, is a reminder, how do you find the midpoint? Remember, I don't have the formula there, but isn't the formula average of the x coordinates, comma, average of the y coordinates? And that just happens to be making use of those 2 points on the top there. So, so there's that from the first section. Here's another. By the way, I'd much rather go with any problems you guys give me. Okay. Here's a problem 14 from the first section's assignment. It asks you to find the distance, and you notice what's different about this is we've got an irrational number as one of the coordinates here. I'm pretty sure we did this one in class back when we worked on it too. So you wind up with, I mean, this is no problem over here. 0 minus a negative 2, that's just 2, and 2 squared is 4. But here, how are we going to square that thing? And that's what I've done over here on the right. So just to show you, if you do need to square a binomial like that, you should do the handshaking step by step. I happen to circle the 2 and the 4 because they were like terms, So, I mean, I didn't write it down, but of course that's 6. And then you've got the 2 like terms in the middle, negative 2 times the square root of 2, and another negative 2 times the square root of 2, giving you negative 4 times the square root of 2. So here's a result of that, which you'll see I plugged right back into the formula. And then you can just go one step below, ahead of that, and now you're stuck. At this stage down here, you're stuck. There's really not a whole lot you can do now, because you've got a root under a root, and this would be your final result for finding the distance. Okay, just checking if anybody's asking any questions. Not yet. Okay, another one from section 1 was number 23. I don't know Again, it's using the distance formula. You know, I better look that one up. That's number 23 just to get the directions here. So from section 1.1, number 23, oh yeah, it says the distance is 5. So that was different. Instead of find the difference, they gave you the distance. So that's a little different. So I just literally plugged a 5 in there. And then when you work on your problem and get down a little bit further, you wind up squaring this x minus 1. Don't forget about the middle term. And finally, you're at position. And now we gotta solve this. So we got to get rid of that root sign. So the next step below the red line is square both sides. And now, if you get the 25 out of there by subtracting it, you wind up with a quadratic. So this goes back to the old algebra days. And you try to factor it. This one was factorable. And so we were able, by the way, question for you guys. Oh, Seth has a question. Can we do problems finding the equation that's parallel? Yes, we certainly can, Seth. And I will do that next. Yeah, Seth has a question. We worked on find the equation of a line that's parallel or perpendicular to a line that's given. 53 and 54 in the review. Thanks, Seth. Appreciate that. And by the way, I'm only going on section 1 because that was by popular choice the one that needed the most review. You can ask section 1 or any other questions, and I like the fact that you picked that from the review, Seth. So, but I have a question for you guys, usability. I think I asked you this last time. Right now I've got this scrolled up as high as it'll go. Are you guys able to see on the bottom that 4 equals x and x equals -2, or is that partially covered by pictures?
You can see it, you just have to move the pictures.
You guys can move the pictures?
Yeah, they're removable in the upper, like, top middle section. There's an option to remove them.
Thank you. I got to try that. Hide participants. There we go. So on mine, I've done that too. So thank you. Did everybody catch that? That was a great tip there. Okay. Now, so anyway, to finish that one up, after we set it, we were able to factor it, and then of course we found out there were 2 such values of x. And I got to just check back on that particular problem. That's all they wanted was the x, so that one is done. So I don't know if anybody has a follow-up there. I'm going to now go to the question Seth asked me, 53, 54, on the review. So, okay, let's start with 53. I'll just put a slide right here if I can get my mouse over to my other monitor. So we're going to do an insert. And I'm going to take my keyboard off so I can write a little bit better. Okay, so this is review. I guess we don't need red here. Review number 53. So in the review, we've got a point named 3, 6, and find the general. So I take it, Seth, from your question, you want me to hop right down to like a 53B or a 53D. Let me know if that's not correct. So I'm going to do part B. So we're supposed to find a line that goes through that point up there and is parallel to 4x plus 2y equals 7. That's a really good question, Seth, because I mean, this is really important to me, and I'm fairly likely to include questions of this type. So the first thing you got to do is, if we're parallel to this, I need to the key is our slope must be the same then, right? Because parallel lines have the same slope. But I can't see the slope. So we need to do some algebra on this equation here. The first thing I would do is subtract 4x from subtract 4x from both sides, and then get rid of divide by 2. So now we have that same equation in a different form. Now I can see what the slope is. The slope is -2. So therefore, our line has to have the same slope. So already we know this much. Our line has to begin this way. But we don't know the y-intercept, so I'm going to just call it B. And now that point comes into play, right? The point -3, 6, I believe, if I read the problem right, our line goes through. So now we come back, substitute that in. 6 goes in for y. -3 goes in for x. And you can all see that b equals 0. So therefore, come back. Remember, this was our slope, and now we know b, so you can either say -2x plus 0 or just leave it like that. That would be the answer to part B. And then, Seth, I'm going to go ahead and do 53D while we're at it, because this was the parallel problem. Let's do the perpendicular part. So part D, same point. I'm going to repeat it because I've scrolled it off the screen. -3, 6. And this time we're perpendicular to 3x minus 2y equals 2. Again, I can't see what the slope is there, so let's do a little algebra and get it in y equals mx plus b form. So start by subtracting 3x from both sides. And then we'll divide both sides by -2. Right? Everybody see that? A -3 divided by negative is a positive 3/2, and a positive 2 divided by -2 is a -1. So here's the slope of the given line. Our line is perpendicular to that, so what should our slope be? The negative reciprocal of that, right? So now we know our slope is -2/3. And then, it's always the same to finish these off. All we got to do is find B and we're done. So substitute in a point. Plug in a -3 for x and a 6 for y. Negative times the negative is a positive. Right? So a negative times negative is a positive, and the 3's cancel. So I just get 2. And it's pretty easy to see that B has to be 4. So then just come back into that equation where we knew the slope. And now put the B in there. 53D. Welcome, Rex. So I don't know, Seth, do you want me to do another one, or was that kind of what you were getting at with your question? And anybody else can pipe in and let me know if you have a follow-up question or anything of that type. Okay, I'm not hearing at the moment, so I'm going to just keep moving here. Here's another one from section 1. Yeah, I think we've seen enough of those. How about this one, 27? Yeah, this is, do you remember this problem? Just remember, sometimes you have to do multiples. So this question 27 from the first section was seeing if you could find not just the midpoint, but points that divided it in a different number of times. So this one said, use the midpoint formula repeatedly to find the 3 points that divide the segment into 4 equal parts. So after you find the midpoint, then you got to find, so it's like you start off like this. Let's see if I have enough room to do this. It starts off like this. You take a line, and the first step is find the midpoint of that. So where's my midpoint? Right here. Except I didn't have the right tool. The midpoint would be approximately here, right? So, and then you got your 2 original points. So now we've divided into 2 parts that are equal, but now you got to find the midpoint of this first segment here and the midpoint of the second segment. And now you will have found, 3 points that do really divide the segment into 4 equal parts. So it's just a matter of doing the midpoint formula 3 times, but you do wind up with results like you see on this page where, you got to do a little bit of algebra, and you got to remember, how do you average? Oh, you got to add the 2 up and then divide by 2. And so you see, like right here, just look at what I just circled in red. You've got something divided by 2 and divided by 2 again, which it looks a little awkward, but that's really the same as dividing by 4. So, I don't know if you remember, but we did work that one through. Let's see, just a couple more we'll look at in section 1. 29. Well, what was different about that one is, it's a similar thing, divided into 4 equal parts. Okay, I think what I'm going to do is, except I don't have the keyboard here, let's see if I can do it this way. No, I guess I need the keyboard back on. Excuse me a second. So, I need to go back and just look at our survey. If some of you were not online a little while ago, there is a live survey. Here it is. I'd like you to respond. It doesn't look like we had any more votes. Right now, the three bars you see are the ones that were the most popular. So far, everybody, the majority chose what we were working on, section 1. Okay. I'll go to the limits. All right, so that was section 5 because we had, what, 27% of you respond with that. So I am going to move over to section 5. Any specific questions like Seth asked? That's wonderful. Please do that. So here are a few problems from the limits, what was it, chapter 1.5, the limits, which was this. So this is number 40 on that particular assignment. You were asked to find, whoops, all of a sudden I got the wrong, there we go. You were asked to find, the problem is above the line there. Find the limit of that. Well, as you know, the first thing you can do is just substitute. And look, that works in this case. If you plug in a 2, you got to do a little bit of trickery down here because you get a 1/2 on the top and you get a 2/1 on the bottom. You got a what? I'm sorry, 1/4 minus a half is negative 1/4. So you get negative 1/4 divided by 2/1, which is negative 1/4 times, flip it over, 1/2. and then you can get your final result. But wonderful because in many ways, because what? Substitution worked. So that's nice. Here was number 49 from that assignment. And here we had, this was a little tricky because if you look at the graph, you see that the left hand and the right hand limit did not agree. You know, I got the left hand limit down here on the bottom, and there's the right hand limit, and they don't come to the same spot. So I don't know if you remember this, but when the left and the right hand limits do not agree, we say the limit does not exist, and we frequently use the abbreviation DNE for that. Another one from this section, here's problem 53. It says, find the limit of this thing. Well, can we substitute a 0 for delta x? No, because of this right here. If you substitute a 0 in, you get an illegal calculation. So that can't be done. But what can you do on the top? I didn't show it there, but can't you multiply that out? So that top became limit as delta x approaches 0. And then you multiply that out and you get 2x plus 2 delta x minus 2x over delta x. Still can't substitute, but what can you do? You can simplify. Just by the way, it's important when you go another step to copy the limit requirements. 2x minus 2x is of course gone. So we're down to this. I still can't substitute, but glory be, I can cancel. And so now you're down to actually this. What's the limit as delta x approaches 0 of 2? You can substitute. There's nothing to substitute in. It's just good old 2. So here's a case where substitution did not work. And we didn't have to go to factoring or conjugates, but just algebraic simplification allowed us to get rid of that delta x on the bottom where we had our illegal limit result there. Here's another one from that page, number 56. And here was a case where when you tried taking the limit of this, you had that dreaded 0 on the bottom again. At this time, no algebra is going to get you out of this one. And we really had to go to what? Multiplying top and bottom by the conjugate. Remember the conjugate? It's that same binomial that we had on the left, only, you know, the opposite sign. Instead of minus, plus. Because what will happen on the top, when you multiply, I mean, you're going to get a mess on the bottom. Here it is. There's no getting around that. But on the top, because you're multiplying conjugates, you get the difference of 2 squares. So the first thing squared is this thing right here without the square root, minus the second thing squared, which is this thing right here without the square root. And of course, that just comes out to delta x. And now, praise be, you can cancel the delta x. Now does substitution work right here? It does, because even though there's a delta x in the bottom, what's x plus 0? It's just x. So you get this square root of x, square root of x, which is 2 times the square root of x. So here it is. Here's your limit. Okay. Again, anybody? Seth, thank you for the specific question. Anybody else who has a problem to work on, let me know, because otherwise I'm just trying to follow your recommendations on the general sections you thought needed the most review. Let's take a look at number 61 on the limits assignment. This one says, find the left-hand limit Remember, that's what this thing means right here. Find the left-hand limit of 1 over x plus 2 as x approaches negative 2. Well, you all know that at x, you can't substitute, because then we'd get a 0 on the bottom. So here's a case where looking at the graph really helps. And this is just a cousin. This one here is just a cousin of this guy, isn't it? You guys all remember the reciprocal function? Looks like it does here in black. But the difference is ours is what? Shoved to the left, too. So it's like our new 0 is this red. Okay? So now, if you look at this graph with the red x and y axis, what happens to this graph as x approaches negative 2 from the left? As it approaches, I don't know, hopefully you can see my cursor, but as it approaches from the left, we're riding down this thing, aren't we? And do you see that we're approaching negative infinity? This is going really low. So here's a case where you have to look at a graph to really get the results. So that's a little bit different. We had a little bit of that. Would anybody like to add a question from the limits, the 1.5 section? Just let me know, and I will take a look at it. If not, then what I'm going to do is look back at the results one more time. And continuity, well, that's the section we just got done with, so let's take a little more look at 1.6. That would be the third most common poll result. So let's come back here, and now I'm going to go to 1.6. Again, let me know if you have a question. First question that I thought we could talk, I mean, we just talked about some of this the other day, just yesterday, but number 11, I don't have the equation written up there. Let me write it out. On number 11, we have f of x equals x squared minus 1 over x. And you're supposed to find out when is this thing continuous. Well, you can see right away x can't be 0, right? A lot of you did that in your quiz. You did a nice job of pointing out that the denominator cannot be 0. So it can't be 0. So we know it's discontinuous at 0. In fact, if you look at the graph, sorry, it's a very crude graph, but the graph has an asymptote at 0, and that's really it, right? So it's continuous on the left branch from negative infinity all the way up to 0. That's this dimension, you know, you're starting over here. All the way up to 0, it's continuous. And then it's continuous from here forever, right? From just past 0. So that can be summed up right down here, right? We've got two parts to this continuity. What are the two intervals? Negative infinity to 0, and then from 0 to positive infinity, we're good. So that was number 11. Here's number 17. I think some of you did this on the quiz, didn't you? Yeah, I can't be as complete here, but number 17, what kind of a domain do we have? Well, we can't have x squared be 1, like a lot of you pointed out. And what are the 2 times x squared can be 1? When you take the square root, remember, you got to take both square roots. So there are 2 of them, right? And sure enough, if you look at the graph, I've got it for you down at the bottom here. That's what it looks like. Can you see? Sure enough, if x is negative 1, that's going to give you this, what? That's where that asymptote is. And when x is positive 1, we got an asymptote too. But anywhere in between those, and to the left and to right, we're okay. So we have three intervals of continuity, from negative infinity all the way up to -1. Then anything in here is okay, up to between the asymptotes, and third, anything over here. So hopefully there's everybody by now. I hope you're into the interval notation. Almost certainly I will ask you a question, something that will include interval notation. So let me know if there's any issues related to that. Okay. Number 21, again, some of you chose this for your quiz. What about the continuity of this? You guys were real sharp at saying, well, that denominator can't be 0. I can't tell when it's 0. Oh, I can, because I can factor it. When is that equal to 0? I didn't show that, but when is that equal to 0? You know, kind of with a question mark. That's equal to 0 when x is 4 and when x is 5. So those are those are two things we can't have happen. We can't have that happen. So you notice we have a barrier at 4 here and a barrier at 5 here. I mean, you don't have to draw those, but that's why we have a three-part answer. And by the way, now I can do this too. Go back to the web browser, and I'll go to Desmos. This is kind of nice. Now I can freely move around and I can actually show you this stuff. And so let's just quick graph that. We've got x minus 5 on the top. Always good to put that in parentheses. And on the bottom we've got x squared minus 9x and plus 20. Okay, what did I do? Oh, yeah, and okay, what did we say a few minutes ago? A little conflict here. We said it can't be 5 either. Okay, what did I do on Desmos? 9x plus 20 minus 9x plus 20. So at 5, when you plug in a 5, what do you get? 25 minus 45. Did I factor that correctly? If you factor this, you get negative 4x, negative 5x, which adds up to 9x, and you get a plus 20. Okay, so why is the graph not showing that we have an asymptote at 5, or something at 5? Yeah, go ahead, speak up. What am I missing?
Don't the two x minus 5s cancel, the one on top in the numerator and the one on the bottom in the denominator? And then you just have 1 over x minus 4, so x equals 4, or x cannot equal 4?
Right. Well, that's true, but you can't. X still cannot be 5, because watch what happens if you take 5 on the bottom. 25 minus 45 is what? Negative 20, and negative 20 plus 20 is 0. So you can't have x be 5. So this should be, there's a problem here at 5. You can't have that. So, I don't know, something Desmos is missing here, is not showing. X cannot be 5. So you're right, you can cancel, but in the domain you still have to consider the original problem. So that's a lesson, and evidently Desmos missed helping us there. See, here it's undeniable, x can't be 5. So anyway, this is a correct answer here. So yeah, you're right. The canceling can be done, but x still can't be 4 and it can't be 5. So there's a case where maybe Desmos actually misleads us a little bit. Okay. Yeah, 23, I don't think anybody chose this, but that was that step function. If you look in your book, it looked like this. I told you I would only use a single bracket, but the book uses this. So the question is, where is that continuous? Well, if you look in your book on page 70, you'll see the graph. I don't have time to duplicate it, but it's a step function. When is it continuous? Well, from -2 up to 1, but not include up to -1, but not including it. Then solid dot at -1, solid up to 0, but not including it. And you wind up with all these little. Each of these is a step, and of course, that continues forever. So that one, you needed to use some notation like this in order to list the continuity. All right. What's next? No, I don't know. I don't know where you guys want me to go. I'm going to skip ahead a little bit. How about 31? So 1.6, number 31. Yeah, it's another step function again, so you got to do this 3-part thing. How about 33? Some of you did this one for your quiz. What's the continuity of that? First, you got to find what? This composite function here. So you had to what? Plug plug this thing into x, and that gave you this. And almost everybody said, well, x can't be 1. You're right, it can't. It can't be any number smaller than 1 either, right? Because if x was smaller than 1, you'd get a negative under the root. You can't have that either. So basically, 1 is okay. No, 1 is not okay. But anything after 1 is. So you notice I've used the rounded parenthesis here, not including the 1, but anything after it. So anyway, you guys, again, those of you who chose to do that on the quiz did a good job. Okay, let me pause for a second. This is not the way I wanted it to go. It's okay, but I wish I'd have gotten more questions. Maybe you just didn't have a chance. Anybody out there want take a look at the review that wants me to do something? I mean, I've still got we still have about 7 minutes. I would love to do the questions you want me to do. So shoot them my way. Still not hearing anything, so I'm going to, again, pick some problems out. How about number 43 on 1.6? That was one of those piecewise functions. See, they've got the 2 chunks there at the top. So you literally get 2 pieces of the graph, the black piece and the blue piece. And of course, they miss. And the question for 43 is, sketch it and find the intervals which it's continuous on. Well, the black is continuous from -infinity up to 0. That's this part. And the blue one is continuous from 0 on. See, this one's got a solid point right here, so that's why that's a square bracket. Okay, so here's a case where, no, it's not, the whole thing is not continuous, but there are 2 continuous parts to it. So you could answer 2 intervals of continuity. Is 45 the same kind? Oh yeah, that's the one some of you chose. We went through this in class last time, so I'll skip that one. How about um, what's going on number 53? Okay, I didn't really show much, but it's a picture in the book. It's it looks like this. Graph looks something like that, and you can see it's everywhere continuous. So that one was fairly easy. Um, so we're getting close to 40 minutes here. 50 minutes, excuse me. Did anybody have one you want to ask about? Otherwise, I'm thinking about hanging it up here pretty soon. I'm going to just go back for my own good and turn on your pictures on the bottom so I can. Okay. Anybody? Question? Oh, we do have review 33. Thank you, Jared. Review 33. Okay, let me shift gears a little bit here. Review 33. Okay, here's review 33. I got to get my book there. Review 33 says, can you complete the square to write the equation in a standard form of a circle, and then, because you'll have it in standard form, you can tell me what the radius and the center are. So here's the problem. You can see we don't. First of all, I gathered the x's together. At the moment, that's missing and that's missing. Okay, so make believe those aren't here. I'll just take them out. So after you gather, you've got this, don't you? And how do you get the 7 on the right? I just added this -7 to both sides. So now we're kind of set up for completing the square. Remember, the process is take half the b term, that's the 10. Half of 10 is 5, and 5 squared is 25. Of course, if you add it on the left side, you got to add it on the right side. And this guy, half of 4 is 2, and 2 squared is 4. Of course, if you add it on the left, you have to add it on the right. Okay, now this can be written as x plus 5 squared. This can be written as y plus 2 squared, and then when you add over here, you get 36. This is the standard form of a circle, and I can see the center is what? What number is being subtracted from 5? Be careful, -5. What number is being subtracted from y? -2. And what's the radius? Just the square root of. So yeah, there's one of those, and thank you for asking about that, Jared. Appreciate that. Any other questions? I think it's looking like that'll be it then for today. Thank you very much for joining in and contributing, and I look forward to seeing you tomorrow. I'm also assuming everybody was able to see everything. Nobody squawked. We'll talk about that tomorrow, but it looks like things worked just fine. Thank you.